All right, everybody, welcome back from lunch. Time to start our talks again. So, ANDiXOR is a secretive cabal of electronics hackers who have turned their focus towards artisanal electronics. For the last 2 years, they have been the brains behind the incredibly popular independent electronic conference badges distributed at DEF CON. These badges, featuring Bender Bending Rodriguez, are filled with games, puzzles, wireless freak jobs, and lots of blinky bling. The ANDiXOR crew are one of the most public faces of badge life, a community dedicated toward what we're calling a demo scene of hardware. Their talk today will be about the engineering journey of prototyping, designing, testing, manufacturing, and distributing their own artisanal electronics. So please welcome to the stage Zap and Hiron, 2/5 of ANDiXOR.
All right, thank you, everyone. Hey there. Well, can they hear you?
I guess so.
There you go. All right, so I'm Zap, and this is Hiron. And as Brian said, we're 2/5 of ANDiXOR. The others couldn't be here today with us due to some issues, but you get us. So we're here to talk about the engineering behind electronic badges, and it's more than just blinky lights, right? So we have blinky lights and screens. There's a lot more that goes into delivering a project at scale. We had 500 badges last year, and it's a phenomenal amount of work. It takes all year. There's really no break. That's why we call it badge life. So just to get us started, this is in no way related to our employers whatsoever. These are all of our own views. It's our own intellectual property. So if your employer's in the room, just letting you know.
And legally that applies to me, even though I didn't say it too.
Yes. Okay, so some of our badge teams. So I'm Zap. We have Hiron. There's also Bitstream. We have Lacoste AEF. We have Excelsior, Rick Astley, and that's it. So we make stuff. We drink beer in no particular order. We have bachelor's, master's, and a PhD candidate here in computer engineering, electrical engineering, computer science, applied math systems engineering. So lots of engineering experience. We do this in our day jobs as far as managing projects and actually delivering real systems. So we also apply it here to delivering badges. The most important thing is we are obsessed with the badges just as much as everyone is that tries to get our badges. We're equally obsessed. So it turns out if you want all of the badges at DEF CON, go make 500 of them, and then people will trade you.
It's a self-serving project.
It works. So some of our favorites, for me it started at DEF CON 18. So we have the Joe Grand badge up there at the top. That was, turns out I was pretty lucky to get one. They found a random box when I showed up on Friday, and I got my hands on it. CypherCon Cube, if you've seen that one, if not, Google it. It's an amazing work of the toy makers. And I heard they're working on a Cube, or something, for not Cube, but something next year. Of course, the Ninja badges from DEF CON 18 and 20. The bottom left, that's the Crypto and Privacy Village badge from DEF CON 23. So one of our guys, Jorge, actually worked on that. That was the inspiration for me getting into electronics. And then the QueerCon badges are always amazing. They always surprise us with something at the last minute. So we decided, why not start making our own, right? We're able to make things, but it turns out it's really more engineering than just making. And so what we're going to talk about is, okay, you can make things blink, you can make screens, do things, but to scale that up into something that is actually, you can actually give out to hundreds of people at a conference and make it work reliably is a lot harder than it seems. Just some background. So what we did at DEF CON 24, this one was basically just Bender. So this was an STM32F103. It was an ARM Cortex M3 with 128K of flash, 20K of RAM. We did throw a little RFM69 radio on there. Turns out that didn't work very well. We had some issues with the RF. We had a little OLED screen. We were able to push about 80 frames per second of video to the OLED, so that's kind of cool. We had the ever popular NeoPixel LEDs. A tilt sensor, so when you flip the badge upside down, the interface, the buttons all switch around so that you can actually use it while wearing the badge. Turns out that's a very nice feature that people like. It also drew about 30 milliamps during full bling mode, which I'll get to in a second why that's so important, and then 2 megabyte of NAND, and it ran Arduino. Last year, you probably saw this one. I'm actually wearing one. This was based on the Rigato BMD300. That's an NRF52 from Nordic, ARM Cortex M4F. We went up to 512K of flash and 64K of RAM. You lose a lot of that to the soft device for the BLE, but we were able to make it work for us. I think we used about 220K of that of that flash. I was running BLE 4.2, so we didn't have any of the RF problems we had the year before with the integrated antenna and everything just built into one package. It's a really nice little device. We upgraded to a color LCD. We had that running about 22 frames per second. I have a slide on some of the engineering that went into making that work, especially over an 8 megahertz SPI bus. 15 of those same NeoPixel LEDs, also a pain. We'll never do those again, that's for sure. The same tilt sensor. We actually dropped, even though we went up to 15 LEDs, our overall current dropped to 28 milliamps. And then when you add on one of these brain slugs, which we open source, you go up to about 53 milliamps because there's absolutely no power saving going on there. Micro SD card, we gave everyone either 2 or 4 gig SD card and a whole bunch of puzzles and unlocks that Hiron actually baked into the system.
I'm not just a hand model that holds a badge. We'll get there.
So for next year, we redacted everything, sorry. The one thing I will tell you is that the trolling on next year's badge is going to be a whole lot greater. We're working on it now, we've already proven that it works, so just hold on, it's gonna be a lot of fun. Something completely unique we've never seen before. So that's the only thing I can reveal. But back to 25, so we upped our bling from about 20 different bling modes on the previous vendor to about 2,800, if you count all the different permutations. We also added a thing called Bring Your Own Bling Mode, and that's the same thing you see on the Hackaday badge, right? So we gave you instructions on here's how to convert any GIF or AVI, MPEG, whatever with FFmpeg, and you can actually put it onto the badge really easily. So we wanted to make that barrier to entry on hacking the badge very low, and we want to see people share those animations. You could do the same thing with the LEDs, although I don't think many people took advantage of that. Games, we ported Flappy Bird and our Ski Free from the previous year, added color to them. We had a Chip 8 emulator. If you saw my Twitter post on the poll on that, turns out not many people used it, but it was about 2 months worth of work writing that emulator and making all the opcodes work. And it was about the same amount of time for Hiron to go through and test every single one, and then submit all the bug reports to me, and then me telling him, no, that's a feature. But it was a lot of pain. If you have a badge, check it out because it was a lot of our time and energy to make that work. The booze hacking, so if you're familiar with Medea vodka, those vodka bottles have an LED strip on them that runs over Bluetooth, and so we reverse engineered their protocol and we're able to have it display any random message we wanted. That was a lot of fun. We also found a case of them, thanks to Bill. A thing called ticklish scripting, so we poured a tickle interpreter to it so you could actually manipulate some of the GPIO, draw things on the screen, do kind of fun stuff like that. Smartphone terminal, and then badge-to-badge gain, the botnet. We've learned after DEF CON that a lot of folks have actually met up at places like DerbyCon and TourCon and played the botnet game with each other, which is really rewarding to find out that these small groups of people are meeting to go play this game, even after DEF CON's over. Some of the constraints. So badge making is not like a lot of other projects. This is not a Kickstarter, right? Your schedule is fixed. If you miss that schedule, you're toast, right? You're not gonna make any of your money back if you're selling it. No one's gonna change the venue. The people traveling for the conference aren't going to change their travel. It's just, you have no room for movement there. And the endurance of the badge needs to last the entire conference. So 72 to 100 hours is usually what we kind of, it's a rule of thumb we follow. It's gotta be wearable. So you can't give somebody 12 batteries because you have all these LEDs and it's super heavy around their neck. You have to understand they're gonna wear this, they're gonna have other badges, they're gonna have backpacks on, those sorts of things. It should be really easy for them to show off. So if you remember the Ninja badge I had up there with the phone, that was a great badge because it was a smartphone, but I couldn't show it off because I couldn't wear it. So that was one of the downfalls there. It's also got to survive hackers and alcohol. I have young children, I use them, I let them wear the badge and run around the house and find a lot of failure modes that way. It turns out if you buy really cheap Chinese battery packs, the AA batteries just fall out when the kids are running around, which is also what hackers do. It's got to be affordable. So it depends on what you're doing, but the badge should either be free or included with the entry, like here at Hackaday, or the desirability has to be greater than the cost you're selling it for. And then if your goal is you still need to break even at the end of the day. And then it's got to stand out, blinky lights, games, really cool design, which is what we had last year. Excuse me. So, what's that?
Done.
Okay. Okay, so one of the first steps you need to do when designing these badges, and this is what we were doing in August, September, is really what's the purpose, right? This should drive everything you do for the rest of the project. Are you funding a party? Are you funding a village? Is it entry to a conference? Are you trying to pay for your trip like we are? Are you just trying to learn? And so writing those ideas down and determining what you want to do with it, that's how you design your BOM. That's how you design you come up with your funding and your budget. Some of our accepted ideas are bling. We're all about bling. Everything we do is bling. We always like our badges to be hackable, and we want the badges to interact with each other. Excuse me, this is not water. Actually, it is. Some of our rejected ideas have been password cracking. We talked about breathalyzers, and then one of our ideas that keeps popping up is FPGA. But it's like, that's not really an idea. It's not really a function. Why an FPGA? What's it supposed to do? So we've rejected that one every time it's come through. We've also talked about a TV be gone. And then, so once you have your ideas down, take those and map them to generic hardware. And the reason I say generic hardware is if you pick hardware too early, you'll kind of get ahead of yourself and limit what you can do. So identify, hey, I want bling. Well, what does bling require? It requires LEDs, requires a screen, it requires some sort of bulk storage. So put your ideas down, map them to hardware, and you see that in the spreadsheet here. And then when you do that, you want to rationalize those functions with the overall cost. So if you say things like, I want to flip my screen, well, that would require an accelerometer or a tilt switch. Those, accelerometer is about $1 for a part. The tilt switch is about 2 cents. So if you're only doing the tilting, the tilt switch actually makes sense there. And so that's where you go and say, okay, so you have a certain piece of hardware, how many functions is it actually performing? And when you do that comparison, you'll realize that accelerometer is only doing one function, tilting the badge. And then this is also your starting point to start prototyping. So what screens do you want to go buy to go test out your bling? What LEDs do you want to go mess with? You see here we have things like consistent time reference. So that was, early on we're like, well, maybe we should do GPS modules. Maybe we should do cell phones. Maybe we should do radios so we can have all the badges on the same time reference, excuse me. The next thing is to kitchen sink your design. Let's take all of these ideas, as many things as you can, put them into one thing. And your purpose here is to validate your assumptions. So you have an assumption that a certain SPI bus or certain device will work on a SPI bus and then another device will work on I2C. But when you put them together on that particular microcontroller, they don't work together. And we find that if you see there on the top with the Regatta, we found a lot of interactions between the peripherals that we didn't expect, didn't become clear to us in the data sheet. And so we end up moving things around. It's a great idea to write your initial device drivers, to measure performance, measure power especially is important. And this is also the best time to fail because you're failing very early. You can go and correct things in your next rounds of prototyping. I think this is my last slide. Okay, so setting up the BOM. So as you work through those ideas and you kind of narrow down what parts you need, putting that into the BOM, this is probably the spreadsheet I use the most. I already started for next year, is going through and figuring out, okay, what's the cost of all these parts, where I'm going to source it, how many do I need, and that should help drive whether or not a part ends up being in your final design. Because you may realize, hey, I want to sell this for $60, but this part is $5 each. I can't afford that. So the BOM is a great tool for you for doing that. If you do it early on, you can eliminate those parts and those features that are just too expensive to pull off. And I'm going to turn over to Hiron.
Here's the other talking stick,
I'll interrupt you when I can.
the semaphore. So, hey, I see a first error on there. So your BOM is gonna be less than your COGS, your cost of goods sold. What I meant to put on there is, prototyping can be, well, it's more. It can be 5 times, 10 times the final cost of a single item. I bring that up because we're here not just showing, how do we take our project and scale it up and manufacture quantities of them. It's because we get approached by other folks too that say, hey, I have a good idea. I have this thing I made on my workbench. I don't get how, you have a BOM worth 40 bucks, but it costs this much instead. And you don't realize, well, when you make something, it decreases in value when you get quantity. You have logic analyzers and scopes, and you have a lot of equipment that you have to buy to do that in-house testing.
A bag of parts does not equal a badge.
Yeah. Now, we talked about that. If that comes up again, we're going to send people a Ziploc baggie of sand and parts and say, yeah, that's what $40 gets you. But there's a lot of stuff that goes in there, and overall you have to think about what's the goal of your project. What are you trying to do? We have 5 friends that are trying to go to DEF CON for a week. hotel rooms, we want to fund the EFF, we want to get some money to get some drinks, go to parties, and so we accumulate all of that, what's it take to travel out there, and that's what it goes in there. And that, in addition to what's it going to take to test and deliver all this stuff in-house before we go to, you know, final prototypes, before we go to manufacturing facilities. So it adds up, and people have to realize, like, just because I make one unit, it's not going to scale that way. So that's where funding comes in. And, you know, a lot of people see different types of funding. We had a mixture of all. We had sponsorship from a couple different groups, circled them, like Phobos and Regato. We had auctions, we had sell them at the cash and the con, even go in the middle of the swimming pool and say, hey, jump in here, take your daily hacker bath at DEF CON and buy a badge. Or Kickstarter. And aside from, you know, telling the story of how we did, I'm curious, I'm assuming everyone here has used a crowdfunding place to get something. We're kind of in that community. How many people have actually used one to sell something or to try to back one of your projects? So, yeah, minority compared to everyone else. And I think where the learning curve happens is, you know, a lot of these places don't have clear directions. You know, you have a lot of Kickstarter campaigns that either go out of control, they don't deliver in time. And we brought up, you know, we have a fixed deadline. So we looked at that and we're like, well, we've all been burned before. What were we going to have 100? We're just going to minimize the amount of configurations of each item so we don't have to stress out and, you know, just have one of one item and have a limited quantity. And you start digging through their terms and conditions and realize, oh, you know, you close a campaign, they're going to take 2 weeks, like 10 business days, 2 weeks to collect funds from people. Then your bank puts a hold for 2 weeks before they transfer money to you. But when you have an 8-month schedule from I have an idea to I need to be at a conference with a badge in my hand, having 1 month is about 15% of your time. So trying to take these types of things into account and work with them is crucial if you're going to be using some crowdsourcing campaigns, because it can make or break you. And of course, recommendations, if you're ever going to do that, have a working prototype. Sometimes people try to crowdsource ideas. Ideas are nice, but proof of concept is probably best when you're going through these types of things. And here is the most boring, unsexy, yet important part of when we talk about what we do with engineering versus making something, is just planning. Yeah, Gantt charts. I don't pay for MS Project, but you can go on Google Drive and probably find Gantter or other fun things. On the right side, you see GitLab, how we're breaking down our software baselines. But what I'm doing there, if you've never used a Gantt chart or any type of like finish to start scheduling, is we start at DEF CON and work backwards and realize, you know, I have to get out there has to be shipping. We're working with Macrofab, who was local, and there's time for them to produce items. That means there's time for us to upload designs. And working all the way back, we realized, okay, I need to run a crowdsource campaign in February or January. And by doing that, I can tell when, you know, a couple of our software build or embedded software firmware builds fall behind, or if we have a problem with the component, how it's going to ripple and hit all the dependencies through there. So yes, it's boring, but I think it's a very important thing to do because it gives you kind of a tangible aspect where if you screw up something small, you can see the systemic effect of how it falls through in your project. More of a visual representation of that, I mean, we have our execution timeline, like literally August through June of last year, and you can see from the potato badge, which let's pretend that was real, all the way to like our Regato dev board.
By the way, we open source that schematic for the potato badge. So April 1st, look at our Twitter timeline. I want to see it.
Someone asked me if I had Osh ones, and I put pictures of the purple potatoes too, and they seem to enjoy that as well. But you can see on there, I mean, going month through month, we're, just like Zap talked about, we're going through, hey, I have ideas to, in the first quarter, down select features, start prototyping firmware on dev boards, to, hey, let's start really honing in on what electronic components we're going to pick for our custom board. Make a first round prototype because we know our first round kitchen sink is going to fail. We expect it, and that's good because that tells us, hey, you know, I know my limitations and boundaries, whether it's our own electronic or embedded software constraints or manufacturing reliability constraints, but it helps us to prototype a few times and learn from failure over and over to say, like, I need to scale this up to, like you see all those badges in the bottom corner. I really want to minimize that so I don't end up with a heaping dumpster fire of worthless badges.
And right now for DEF CON 26, we're at the kitchen sink phase. So we're going through and validating a lot of our initial hardware selections. So we're kind of tracking to the same timeline already, although there is no Gantt chart, Hiron.
Yeah,
Yet.
I'll copy and paste the previous one and shift it over. We'll get there. But as you can see, I mean, that's where our first protos came in. You can see like our little red macrofab board and then some of our panelization and the final stuff that came through. So prototype, back over to you for this.
Yeah, so prototyping, once you kind of have the BOM, the important thing here is take your design and put all of it onto one board. And the purpose here is to really to finish out those features and to do some of your testing, and then revise as needed. So for last year, we did 3 different revisions of the prototype. We had some manufacturing issues in the middle. I can't stress this enough. Put test points all over. Break out every I/O you have on the MCU. And the reason is then you can hook up your Soleil or logic analyzer or whatever, and if something's not quite working right, you actually have a place to go test rather than trying to solder on this little wire on a pin somewhere. So just think ahead, put those test points on the board, remove them in the final design if they don't look right, but at least during prototyping have them there. This is also an opportunity to explore design ideas. So work with whoever you're doing the fab with to explore, hey, if I do this negative solder mask, does this look right? If you look on the back of that particular badge, although you can't see in that picture, I had 4 different versions of one of our sponsors' logo because I wasn't sure how the dithering would look on the solder mask. And so it was an opportunity to pick which one looked just right. There's also an opportunity to test like manufacturing. So are the LEDs that we selected, can they actually go through an oven? Turns out, no, they can't. So we had to rev the prototype a little bit. It also gives you an idea of what the overall cost is. So what's the actual cost to produce one badge? You can determine that from the prototype. And then less emphasis on fail. You should fail here. You don't want to fail in production, but you should be failing here. You should fail early, but definitely try to knock out all those issues early. Last processing. So this is how we did the really nice, silky, smooth animations with an 8 megahertz SPI bus. So we took GIFs and MPEGs, converted them through FFmpeg to put them into a raw format. The NRF52 is limited to 8 megahertz, and so if you have a 320 by 240 screen with 16 bits per pixel, that's 1.2 megabits per frame. 8 megahertz is 6 frames per second. If you drop down to 128 by 128, you get about 30 frames per second. So even though you saw on the kitchen sink, on that one of those green boards, we had one of the larger screens, we actually end up on the final badge, we ended up with the smaller one, just to reduce how much data we had to push per second. Our solution, and this is a little screenshot here from our Soleil, was, okay, so the first thing was just get the driver to work. I think we're running at about 1 frame per second with that one. Once we turned on DMA, we were able to blast a lot more data, and I got it to about 10 frames per second. And then we figured out how do we do asynchronous I/O. So we put the SD card on one SPI bus, and we put the LCD screen on the next SPI bus, and then we're reading and writing at the same time, and just streaming the data across. We got up to about 22 frames per second. So the 2 buses at that time were about 75% duty cycle, and we're only running at 28 milliamps. So that's pretty nice. One of the limitations on the Nordic is that they have this weird limit in their DMA of 254 bytes. Or we were limited to 254, I think their limit's 255. So that kind of slowed things down a little bit, but in the end we made it work. And that limitation so they can handle all the BLE stuff in the background. Battery life. So I mentioned that the battery should last the entire time. So the conference is a few days, but your badge should last that long. We prefer alkaline batteries because they're cheap and safe. You can buy them in bulk from Amazon. They'll ship them for free with Amazon Prime. So I think there's we bought 1,600 and it was like a couple hundred pounds of batteries. You never have to charge them. If they run out, you just throw them away responsibly. Lithium batteries, a lot of folks like these. We're not as big of a fan. They are nice and light. They have high power density. They can be hazardous if not treated well, which hackers tend to do. They're expensive. You do have to charge them. They do drive up cost because the charging circuit requires money. And you can't ship them. You can only ship them ground. So that can add some time to your overall schedule that you need to plan for. Some recommendations, if you're like Rick and Morty, throw a microverse on there if you can invent one. We prefer switching regulators, and pick one that'll get you about 90–95% efficient. You'll get all the juice you can out of those batteries. consider user's neck. So this is where get that microcontroller way down in sleep, get its power consumption way down, so you don't have to put 12 batteries around the person's neck. Consider that they're going to be wearing other badges, they're going to be walking around standing quite a bit. The magic formula we've come up with was you need about 1 AA for every 20 milliamps of battery or of power consumption that you use. So if you have a budget of 60 milliamps, put 3 AAs on there and you should last for about 4 days.
Something else I was going to add, while I haven't seen it happen yet, even though in the past couple days we've shorted out just 2 of our badges.
Yeah.
If you don't go through this badge problem like we do, you have a bunch of them, they clang around, they bang on each other, but they short each other out. The risk of shorting them out while you're using a LiPo battery and hoping that, like if it's an 18650, it doesn't pop into you. It's just something that scares me at times, so we try to separate the LiPo from the alkaline when we do that.
Yeah,
So far, no errors though.
I've shorted the Hackaday badge a few times already.
Oh, so the fun part of engineering. I would do a disservice if I didn't address security, given we go to DEF CON and we deal with what we deal with. But instead, it's more like, what's the security we put in place? You should always design with security in mind for your hardware, or don't, like we did. I mean, we did it on purpose because at the time when we were trying to down select our ideas about a year ago, big thing in the news was the Mirai botnet going around, and you had a bunch of hardware thrown out in the world, a bunch of DVRs, baby cameras, all that stuff that basically had baked in root passwords, default passwords, stupid ones at that too. And we started getting to talking about, yeah, wouldn't it be dumb if we actually made command and control on our gold badges and all the conference badges were part of an IoT botnet? It just kind of drove us to make this mesh BLE network and have a conference, 500 conference badges in a small lolzy botnet. But
And then DC801 does a replay attack on you and controls your botnet.
right.
But whatever.
And I guess that's the important part. I mean, we work with security. We get what you should do at times to make things more secure than not. And it's difficult with a hackable conference badge because you don't want the thing locked down. You want people to be able to exploit it, have fun with it, build on it. But we still wanted to be able to control certain parts of the games and the puzzles because you don't want people cheating at that. And at that point, what happened is people started following us around with an Uber tooth and grabbing traffic, replaying it, twiddling bits, and they twiddled the right bits. And they not only took control of it, they took control away from us. So for the longest time, I mean, as far as payloads go, we had like Rick Astley, or we had stupid animated GIFs going across people's badges. And all they had to do was run a little patch cycle and patch their badge, it would go away. But, it's a harmless payload, but the fact that we made a botnet just for fun on some IoT conference badges and then we lost control of it shows, no one's gonna be able to eliminate threat vectors or anything from your hardware. But in general, you should always try. In fact, I always tell people, well, if you're making any kind of project where you're gonna scale up, make a lot of them, maybe even use a crowdsourcing campaign, please don't put default passwords in it. I buy things off Kickstarter and Indiegogo just for fun to mess with them because everything I buy with a Raspberry Pi still has Raspberry and Pi as the root password when it shows up at your doorstep, and it shouldn't. It shouldn't even exist as a thing. But I would say for security and all this, we put a tailored amount so we could still have fun with it. Expect failure and expect what you're going to do when things fail. Developmental testing. Obviously, when we're going through this, you don't want to test your own stuff. We have a group of 5 people, so as one person makes something, they hand it off to the next person. We script what we can and make test plans. So I could say, hey, go, it sounds kind of boring, but go in this spreadsheet, go to this tab, run this test plan so we can make sure that the tests are repeatable and we can have regression testing so when one person makes a new module, we can ensure we weren't breaking anything. Then going through integration between our smartphones and the badges and what we call the break shit test, where we just try to go crazy and hack it and do what we can. And going all that, we end up in more of a real world test where we'll go to other conferences, like we went to Layer 1 last year, and we have prototypes. Is it? Oh, good. Yeah, I'd say between Layer 1 and B-Sides, you get more of a representative hacker hostile environment. You get people messing with the RF spectrum. You get to learn things like At layer 1, we learned that we don't know as much as we want to about mechanical engineering and how to place battery packs and how to buy good battery packs, because as you walk around, the batteries jiggle and they fall out.
So do SD cards.
Yeah. So you had to, it's weird to say, think about, you're making a weird circuit board that hangs around your neck, and what's the type of mechanical things occurring to your circuit board, and how do we deal with that? As Zap brought up, testing reliability with toddlers, they're very representative of drunk adults running around on 3 days of no sleep. Red team yourself. And I even think at B-Sides Las Vegas, even though we were really good at sanitizing all our inputs, someone was exploiting a new Bluetooth vulnerability, which can drain battery power very fast if you send values larger than the field should be. And it was crashing our badges. So what happens? You end up reflashing 500 badges in your hotel room while you're out in Vegas. Other than that, I think just hitting to the final part where we talk about production, everything we brought up as far as how do we test it, how do we develop it, how do we source it, it comes down to I need to make a large quantity of these things. And it's not just like running your design rule check. That's kind of, it's not run DMC. He has a run DRC.
Run DRC.
I mean, you're going through there and running your DRC to make sure, hey, I have my fab house's limitations or certain constraints. I put that in there. But at the same time, components have their own constraints. At the time, we looked at NeoPixels and APA 102Cs thinking like, hey, that's what everyone uses. They're really common. They're easy to source. But they were meant for small maker projects and one-off and long strips. They weren't made to go into, if you go into an ROH-compliant reflow, those things are going to operate at 240, 260?
Up to 260 is what I've been told.
Yeah, and on the APA 102Cs, if you look at their data sheet, it does not say what to reflow them at, and then you dig into message boards, you start finding out that if you cook them over 220, they just start liquefying and melting and shorting out. So we had picked components that we just couldn't reflow, and we end up having to do them by hand. So you always have to consider, even though it works, can I actually produce it? Can I manufacture it? And you got to work closely with your fab house to see, like, am I doing something stupid and picking something that can't be fabricated?
Which we did. So then you end up soldering 6,000 LEDs by hand in your garage.
It makes for a fun Twitch feed, and I'm surprised how many people watched us solder for 2 days straight on a Twitch feed. But all that ties together. Your part sourcing, I mean, if you consider that, there's 16 LEDs on here? What if I made 1,000? That's 16,000 LEDs, and you have to think about, if I go to DigiKey or Mauser or any other places, like, they have a limited number of reels. If you use up a certain quantity, there's bare minimum 6 to 8 week lead time. So it's this balance of, do I make enough, not enough? Am I gonna make so much that all of a sudden I have a 3-month wait time because the factories have to make more? So all of that is what we try to take into consideration when we figure out what we're gonna make, how many we're gonna make, and make sure we test the manufacturing process and run prototypes through to make sure whatever we make and engineer is gonna live and get us to where we wanna go. So that's
it.
about it.
Do we have time for questions or?